This question is like the previous question, 8, and that a student is asked to conduct an experiment. But this one is specifying the conditions more closely. So there's a block pulled across a horizontal surface by a spring scale with some force. So there's a non-zero change in momentum. So our change in momentum is m delta v, which is also equal to f delta t, which is equal to the impulse. But we're primarily looking for the change in momentum. And we're looking for a specific time interval. Has access to tools found in a physics laboratory. Could they conduct to determine the change in momentum of the cart? Select 2 answers. So we've got a spring scale on the block. Pull it at a constant speed as it travels across the horizontal surface. Well, if there's a constant speed, then delta v is 0, and the change in momentum would be 0. Not possible to get a non-zero change in momentum. The next one, we attach a spring scale to the block, which will allow us to measure the force. Pull it so that its speed increases as it travels across the horizontal surface. So we've got a force, and we have a change in speed. Record the force, and use a stopwatch to determine the time. So we have F, and we have delta t, and we have a change in velocity. So all we need is actually the force and the change in time to give us the change in momentum. So B can definitely be done. Next, we've got a spring scale again. The speed increases again as it travels across the surface. So it's identical to the first sentence. Motion detector to record the speed at the beginning of the time interval and at the end of the time interval. Use a mass balance to determine the mass of the block. So we will have m, we will have delta v, and that will give us delta p. We don't need the spring scale, but we can get the value nonetheless. So it looks like choice C. And then lastly, the spring scale, its speed increases. Use the motion detector to record the speed of the block at the beginning of the time interval, at the end of the time interval, and use a meter stick to determine the distance traveled by the block. Well, if we've got a motion detector, we've got the speed at the beginning and at the end. We need the mass, and nowhere in this one does it say that we get the mass. We've got a force. And we do have a time interval. So we do have a force we could get from a spring scale, but it doesn't say anything about the spring scale force being constant. So we would need to have a number of measurements because it's the average force times the change in time. So we have the delta V, we have the T, we don't have the M. It looks like choice D would be acceptable as well. Should be acceptable as well. But the problem is really getting the data from the spring scale. We need multiple measurements of the spring scale to find the average force. And there's nothing here that says we need to have a constant force or make multiple measurements. And it also doesn't say that there is constant acceleration. It just says to make the speed increase. So I would say that although D could be true, could work, B and C will work. And that's why it's B and C.